Good evening, everyone, and welcome to the National Science Week webinar series hosted by the Cape Town Science Centre. My name is Amisha Canterbury, and today I have the honor or privilege to introduce our guest speaker tonight, Mr. Ridaa Manuel. Mr. Ridaa Manuel will be talking about building sustainable energy systems in South Africa. So, I'm going to quickly read a little bit more about Mr. Ridaa before we continue. Okay, so passionate about empowering others through knowledge and innovation, Ridaa Manuel is the coordinator of the Energy Storage Graduate Program at the Energy Storage Innovation Lab at the University of the Western Cape, and also the founder of the Green New World, and a company with a vision to build a renewable energy system that can solve the energy problems of Africa. Ridaa Manuel studied mechanical engineering at Cape Peninsula University of Technology, also known as CPUT, and graduated with 8 distinctions. He has worked in the engineering industry for the past 10 years and is currently doing his master's in energy with a focus of solving the energy problem in Africa. Mr. Ridaa Manuel will be speaking to us about building sustainable energy systems together as a community, and also, National Science Week is an initiative of the Department of Science and Innovation, also known as DSI, implemented by the South African Agency of Science and Technology Advancement, SASTA, a business unit of the National Research Fund. So, are you guys ready for this evening's talk? Mr. Ridaa, are you ready?
Yes, I'm ready. Thank you so much for having me, and thank you so much for the opportunity.
Okay, so I'm going to hand over. Thank you so much. I hope you guys enjoy your evening talk, and I'll see you guys in a little bit.
Okay. Just checking, can everyone see my screen? I can see the confirmation that everyone can see my screen. So, any confirmation?
Hi, Rido. We can see your screen, but can you please make it bigger as in the presentation mode?
Is that good?
Um, it's not large enough for everyone to see. It's still in your
Uh,
PowerPoint editor. You can press F5 just to enlarge it. Okay, we can see it now. Thank you so much.
okay. So we're all good to go?
Yes, we good to talk. I mean, we good to
Yeah.
go.
Okay. Thank you so much. Sorry for the technical issues. So, Good evening, everyone. Thanks for joining us. Today we're going to speak about building sustainable energy systems together as a community. So it's two parts to it. So the first part is about there's a current way we're producing our energy and it's causing some problems. And if we shift to a sustainable way, which is more renewable energy, we can solve this problem. So a shift to a sustainable energy system, and then asking the question: is it possible for us to build those systems together as a community? So that's the two sides to it. Just add the laser point here. So as already introduced, I have a degree in mechanical engineering. I'll just add some more points here in that when I studied mechanical engineering, I always had a passion for physics and maths. So doing this kind of work is, it's within my highest values. I really enjoy physics and maths. And then I worked different industries. But all those industries was linked to me building these technologies today, giving me the experience and the skills to build these technologies. And then currently I'm doing my master's in energy. So the whole idea is to design a system, a off-grid system, and sort of build it onto a farm like this, where we will have an eco-village that will be completely off-grid, completely powered by the sun, powered by the waste that's around the farm, and powered by the wind. So designing that system, and this founder of the Green New World is sort of the company we started, which is sort of like a house to complete this purpose of building the system and spreading the system throughout Africa. So currently, I'm a coordinator at the Energy Storage Innovation Lab in the Energy Storage Graduate Program. So I have mechanical engineering students and electrical engineering students, and basically training in energy storage. So that's another thing I'm very passionate about: teaching, training others. So this mission you will see now is very aligned with who I am as a person. So if we could just start off with some of these problems that exist. We have, and as you can see, the headings are there, problems that we need to solve actually urgently. Number one on the list is load shedding. I think that's a very big issue that needs to be solved. So all of these problems exist because of the current way we are producing our energy. And by shifting to renewable energy, we could solve these issues. So number one on the list is load shedding. And it's not only load shedding, it's also the electricity prices. The electricity prices keeps rising and will keep on rising. Electricity prices plus fuel prices, both of it run on fossil fuels, coal and fuel. So, and these prices will keep on going up. As you can see, an average of R2.77 we're paying per kilowatt hour. And this price will continue to go up. So not only the load shedding as a result of the current way we are producing our energy, but also the electricity prices and fuel. Then we have global warming, which is as a result of the current way we are producing our energy by burning coal, releasing the tons of carbon dioxide. That forms a layer around the earth, which traps the energy. As it traps the energy of the sun, the temperature on the planet keeps rising, and this is causing a whole lot of flooding, fires, and storms. From this graph, we can actually see for thousands of years. This is carbon dioxide level, but if you plot the temperature levels throughout the thousands of years, it's exactly the same. It was stable for thousands of years, and then in 1950 we see this spike in temperature. And as I said, if you correlate it with the carbon dioxide levels, you will see a spike in carbon dioxide levels at the exact same point, 1950. And this is proves to us for a fact that the global temperature that is rising and the resulting storms, fires, and flooding is man-made, basically. This is why I put here 97% of climate research today are basically convinced that this is a man-made And it's gone from just being a theory, global warming theory, to now fact. And it's just unfortunate that 80% of the world's activity is still running on fossil fuels. So, and as South Africans, we should be especially concerned about this because South Africa is one of the top producers of carbon dioxide. So we are really adding to the problem. And then finally, one that's close to my heart is Africa without energy. As you can see, at night time, the rest of the world is all lit up. But Africa, especially sub-Saharan Africa, is dark. That's why it's called the dark continent. And as you can see, North Africa is lit up and South Africa is lit up. But the whole of sub-Saharan Africa, that's why we said 90%, which amounts to about 600 million people in sub-Saharan Africa, have no access to clean electricity and cooking fuels. And I feel it is the responsibility of us as South Africans and North Africa, who has the technologies, who has access to the knowledge, to actually assist in solving this problem. And I believe that by switching to renewable energy and building technology, renewable energy technology, we can actually bring energy and cooking fuels to all of these people. So you'll see in the next slide the abundance of solar energy, for example, we have in Africa. So I'm saying here, renewable energy is the solution to all of these problems. We said that the price of fossil fuel electricity, coal-based electricity, is going up. So this black line actually represents the fossil fuel electricity, the price, and as it's going up, and will keep going up. The renewable energy on the other end, the electricity 10 years ago, it came from there was 10 times more than it is now. But in about 2020, it became cheaper than fossil fuel electricity. So it's cheaper and it's just getting more and more cheaper. This will obviously result in cheaper and reduced electricity bills. It's currently in South Africa, you pay less than R1 per kilowatt hour, opposed to R3 per kilowatt hour. So to divide your electricity bill by 3, and then in 2020, like I said, the price of renewable energy dropped below fossil fuels. That's worldwide, and the price of this renewable energy will just keep coming down. There was projects in Saudi and in Portugal where they had solar farms, so they were selling the electricity for 20 cents per kilowatt hour. So yeah, cheap and like I said, reliable because the sun will always shine. If the sun isn't shining, the wind will always blow. The winds are blowing, the oceans and the rivers are flowing. If that isn't flowing, there's always bioenergy, abundance of bioenergy available on the planet. And if all of that fails, we have energy storage. So it must be coupled with energy storage. And then it's clean energy. It's there's no greenhouse gases basically. When we burn coal, we release greenhouse gases causing all those problems. Or when we drive our vehicles, burn the fuel, those exhaust greenhouse gases, adding to the problem where solar energy, wind energy, and all other renewable energy has no greenhouse gas emissions. So that's when we switch to renewable energy, we then obviously reduce this carbon dioxide production, and as a result, it's stabilizing this rising temperature and resulting disasters. And there's just a picture that shows that if we carry down this line, as we saw in the graph, with the temperature continuing to rise, this is how Cape Town will look. Basically, this entire section is flooded. So if you can find your area there, you'll see that you'll be underwater. If we do not change our course that we are currently on, basically move from the current system, current way of producing our energy, to a more cleaner way of producing our energy. And then finally, Africa has an abundance of resources, both renewable energy. This is basically the solar resource that's available in Africa. So we have all the renewable energy necessary to power Africa, as well as the raw materials to build the technologies to access this energy. We basically need to take back the power by using the resource that is on Africa and in South Africa to build our own technologies to solve our own problems, using the renewable energy that's widely and freely available on the continent, instead of giving all of our resources away to other countries, letting them build the technologies and them selling those technologies back to us, and all of our resources leaving the country, and all of our money leaving the country, and not really solving any problem. Then South Africa itself has one of the best solar resources in the world, about 220 watts per meter squared. And it's better than USA and EU. And there's about 2,500 hours of sunshine all year round. So we definitely have the resource to power Africa. And then I'd just like to move on to the further, just what I spoke about now about the problem in that the renewable energy, however, that you want to access is too expensive. So if you want to buy a solar panels for your house, for example, it costs an arm and a leg. And the main reason for this is, so basically not everyone can access it, even though the electricity, the energy is free. We can't afford the technologies to actually access that free energy. And that's one of the main reasons is all of our technology currently is imported from other countries. We give our resources away and we give our money, as we say, away to other countries. This one was just an example. This picture was just an example of how we basically have all this is just for lithium-ion batteries. We just took this as an example. We have, for example, manganese is batteries. We have 80% of the world down in South Africa, and then you see cobalt, 60%. Okay, they are moving away cobalt to more environmentally friendly ingredients. But just to show example, lithium, Zimbabwe is the fifth largest grower, and just to top this off is that we spent about, I think it was about 100 billion last year on lithium-ion batteries. So this shows us we have the resources, but we're giving all our resources to other countries and buying the technologies back. So our economy is going down. All other countries just robbing Africa of its resources. As we have the resources, we just need the knowledge to actually convert those resources to technologies to access the energy that is free and abundant. I just want to do a quick check just to check if everyone is still here. Is everyone still with me?
Yes, Ridaa, we're still with you.
Okay. And then just this is basically showing us that pointer is a pointer. Here we see that we have this platinum group metals. We are the number one. We have the highest reserves of platinum in the world, which shows that, for example, platinum is going to be used in fuel cells and producing green hydrogen, and shows that we need to be at the forefront of building these technologies, not using foreign expertise, using foreign labor. And one of the biggest problems is we lack the knowledge to actually build the technology. And so that is where this topic comes in, is are we dependent on other countries to bring the solutions, or are we dependent on other companies to bring in the solutions, or can we build these technologies ourselves as a community? That is the focus of this presentation. And I think thus far we've seen that we have all the resources. Now this is the missing link here, and this is where sort of the focus of this presentation. We're saying that the solution is that we should make renewable energy, as we saw now, quite abundant in Africa and in South Africa, knowledge and technologies accessible to the people of Africa. And how we're going to do this? By converting complex renewable energy knowledge. So the knowledge to actually build these technologies can be quite complex. The textbooks can be quite difficult to traverse, the English difficult, textbook expensive. And so what we're currently doing through our masters, through working at UWC, to Green New World, is trying to convert this complex knowledge into simple knowledge That's what we're doing now. We're speaking to you on a level that is simple to understand. And that's what we do with all our classes. We convert all this complex knowledge, renewable energy, into simple knowledge, and as well as simple technologies. So this is an examples. We're going to speak about it more in depth later of simple technologies. So both simplify the knowledge and then build simple technologies which the people can build, and then handing that over to the people to build those technologies. So then you actually, the community, builds the technologies yourselves. You solve your own problem. You have access to electricity, to warm water, to cooking fuels, because you built a technology that allows you to convert energy that is actually free, like the solar energy, wind energy, your garden waste, agricultural waste that's outside. So, so as a result, we want to then build these renewable energy technologies that is low cost. As you can see, this is made of plastic bottles, milk cartons, plastic, very low cost, locally manufactured. So you, the community, must build it. The people of South Africa or the people of Africa, depending on where we are, we must use materials that is widely available on the continent, like all of these things locally sourced. Like we don't depend on, like I said, we have the resources, both the materials to build it and the renewable energy resources. Um, and we need to build technologies that accesses the renewable energy resources that are free and widely available. For example, the sun, the wind is free. As you saw now in the previous slides, it's abundant. We have the best resource in the world, and then just teach others to build these technologies. So this is where the solar energy classes come in. There's just a post I made previously, and just put it into this point of the slide where the first part is a bit small for everyone to see, but you're saying that the small part here is just saying that the world currently needs 18 terawatts, and it says 15, but it's actually 18 terawatts. That's the current demand of the world. And so they're saying ocean tides can provide 2 of the terawatts, hydroelectric can provide 3 of those terawatts, wind can provide 4, geothermal can provide 12, bioenergy can provide about 100 terawatts. So as you can see, the bioenergy can already be enough to supply the world. But look at solar energy, which can provide 120,000 terawatts, which is over enough to supply the entire planet. And this is why this next slide says that providing enough energy in 1 hour to power the Earth's activities for a full year. Just to simplify that, if we, the people of Earth, capture the energy of the sun in just 1 hour, all the energy that's coming from the sun in just 1 hour, we can power this entire planet, all of its activities for an entire year. And so that shows you the potential of solar energy on its own, let alone renewable energy and all of these different energies together coupled with solar energy. So I'm saying all we need is enough of the correct technologies to access this energy. So there's different technologies that we can use to access and turn the energy of the sun and turn other renewable energies into different forms of energy. This is a solar geyser, turns it into sun energy of the sun into warm water. You use this as a solar cooker. This turns it into electricity. Again, this you could use this to heat up water, turn it into steam, turn turbines. Again, the same principle here. So there's various technologies that we can build to turn the energy of the sun into different forms of energy. Warm water that we need to wash dishes with, to shower with, solar cookers to cook our food, solar panels to convert it to electricity, to power lights, converting it to warm water, which turns a turbine to produce electricity. And the thing is, we can take all of these technologies, we can study them, and this is where I come in, and this is what I find my role to be, is that we can study all of these technologies, understand the physics principles by which they operate, then use that same principles, that same physics principles, and apply them to build cheaper, simpler technologies. Now this is like the lowest, like the cheapest route in. We're using plastic bottles and milk cartons, plastic. It was the cheapest route in. This was meant and designed for like townships and the villages of Africa, but the communities can come together and build these sort of geysers to provide the warm water for their dishes and for showering. And basically we're applying the exact same principles. For example, this is a high-tech solar geyser, which most people can't afford, but they can afford to make a simple technology which can provide them the same warm water. They have access to, this is basically waste to energy. So therefore, and this is another example of a bit more high-tech solar geyser, but it's basically built using the exact same principles. So just this idea of taking high-tech technologies, understanding the physics principles behind which it operates, and then building these simple technologies. Then taking the knowledge we learned and the technologies, taking it to schools, taking it to classes, and this is a school I was invited to give a class on how to build these technologies, hand over the knowledge to them. And so as I was saying, join us as we simplify this knowledge to make it accessible to the public. So this is the whole idea and the thought process behind the classes and how we can link, as we said in the beginning, the two parts of the presentation: building sustainable energy systems as a community. So how does the community build it? By having the knowledge. How can the community have the knowledge? Like, for example, I can go through this whole process and be the middleman and train others to be other middlemen, understanding the technologies and the physics principles, building these simple technologies, and then handing over both the simple knowledge and the simple technologies to the people for them to understand. So there's just some pictures of all the classes we've had. We've had tens of classes, all that at Eco, at those eco villages, on farms, at schools, at my home, and to primary schools. So this is just showing us that there's lots of people out there that wants the knowledge, that wants the technology, that wants the ability to in a sense, break free from the current system that is sort of, in a sense, unsustainable. It is crumbling, in a sense, to a system that is more reliable, energy of nature, a system that's more in harmony with nature. And so these classes just show us that there are many people that want to sort of make this shift. And it's just sort of summarizing what we want to achieve. We want to take, this is just one example, the sun's energy, for example, but it could be bioenergy. And build it, so there are technologies that can convert the energy of the sun, for example, to different forms of energy. So this is heat energy to wash your dishes with, to shower with. This is electrical energy to power your lights and other devices in the house. And there's chemical energy. So we, like we said, to study the technology, the physics principle, build cheaper, simpler technologies, study it, build cheaper. And this is not mine. I just took this off the internet, but this shows that you can take, for example, bioenergy, put it into a container, it releases methane. As it releases methane, we connect it to our stoves and cook with it, with energy. So the ultimate system you want to build is then connecting all of this up into one system that integrates the different forms of renewable energy. This will give us a more constant supply of energy because the sun, like I said, the sun doesn't always shine, but if the sun isn't shining, maybe the wind is blowing. If the wind isn't blowing, maybe there's bioenergy. And if all of that doesn't happen, we have energy storage. So it gives us, by integrating all of it, we get a more reliable supply. Maybe if you only rely on solar, you can only have electricity when the sun is shining. Or if you have a battery backup system, you can use it. But if you have couple it with wind, you couple it with bioenergy, you're basically getting this more reliable supply. And so, as I said, we build cheaper versions and simpler versions of the system. And so what is our vision, sort of, a green new world, is to start off by building the system we explained now. So we build these low-cost renewable energy technologies that allows us to basically access as many forms as we showed now of renewable energy as possible. So as we build these systems, we have these classes and hand it over. Basically hand over this knowledge we've learned and hand over the technology that we have built. And then the second phase is to live in the system. And this entails not only having an integrated renewable energy system on this farm that powers the farm, but also having um, sustainable farming as well, aquaponics. We can have different systems that's powered by the renewable energy, different sustainable water system where we're pumping the water from underground or capturing the rainwater and purifying that water using the renewable energy system, sustainable housing, made of earth housing. And this becomes in sort of prototype green new world that we build on this farm. So this is what we want to display to the world, display to, that it's possible to build a system that is completely off grid, that is completely sustainable, that is basically you're not dependent on any other system. When you need energy, there's always energy available. When you need clean water, there's always clean water available. And you want to sort of show South Africa and Africa that that is possible. So by building this prototype, we will show that a different way of life is possible. And obviously, this requires a large amount of funding, which if anybody is or any government entity is willing to fund it, to fund the building of this prototype green new world and displaying to the rest of the world, and then we can take that system, that's full solution, and spread it throughout Africa. This is the final phase, which we call spread the system. We move through Africa, so as we build the system, we're developing this network, and we're developing this young engineers and scientists that is empowered to create change throughout Africa, that is passionate about empowering people, and we're taking the system and we're just spreading it throughout Africa. So we're moving through Africa, teaching the people. That's why teaching is an important aspect. In the same way that we could teach the community of South Africa, of Cape Town, to build these technologies, we could, in the same time, then create this sort of army of engineers and scientists that moves through Africa and teaches the village people of the villages how to build these technologies, so that they end up building these technologies themselves, giving themselves access to electricity, clean water, and everything that they don't currently have, and allowing them to do things that they could never previously do, such as have access to internet, have access to knowledge, which can allow them to do the research to build these technologies, allow the businesses to have access to constant supply of electricity to keep their businesses going, and basically light up Africa in this process. In a sense, then the people of Africa build so we move from this prototype green new world to the full green new world. That's the dream, where all of Africa has, the system is built throughout Africa. Everyone in Africa has access to clean drinking water, have access to clean organic food, has access to clean electricity, warm water, cooking fuels, and not only have access, but has an abundance of it. Because remember I said in the beginning that we have abundance of resources. We have all the resources. We're supposed to be at the head of the world, basically. But because we don't have the knowledge to convert all of our resources that we have, we give all of it away, and we basically give our power away. And so by through this vision and through this plan, we can sort of take back that power through knowledge and through training the people of Africa how to build these technologies using the resources that we have as Africans, to build these technologies, to allow them to access the energy that is abundant on the continent, that is free, that is widely available. They don't have to pay for the energy that's coming from the sun, or from the wind, or from bioenergy, and basically solve these issues that exist in Africa and South Africa, and load shedding. I think someone's mic is on.
Ridaa, no one's mic is on.
Oh, there's just a noise, a constant noise in the background. So basically, we're saying that with the correct knowledge, we can build these technologies ourselves. So basically, we went now through why we need, all this solving load shedding, electricity prices, global warming, We went through solving the issues in Africa, in South Africa, and we basically went through a plan on how we can get the knowledge over to people, get the technology over to the people, and train people to build these technologies themselves. Now we're just going to focus. I'm not sure how much time is it. Is it 15 minutes?
Yes, we're gonna continue till 1:15. So you still
So
have, yeah,
10 minutes.
that's 10 minutes. Yeah.
Okay. So in the slide, so we're going to go to about basically just three technologies. So this one is the plastic bottle solar shower we spoke about, made of plastic bottles. So we specifically asked someone to go pick up the bottles from the streets for this model, so we can show the example of basically waste to energy. That we, as we build this technology, we're actually cleaning up the streets, and obviously the people of Africa realize that hey, plastic bottles and milk cartons is actually a resource. They will start cleaning up the streets themselves and building these technologies. We can reduce the piles of waste that's just piling up and convert it into technologies. I know we're saying technologies, but it's obviously very low tech, very low cost, allows the poorest of the poor to actually access this free energy. And and so what we have here is we built a solar panel from it. So basically the plastic bottles trap the energy of the sun. The the milk cartons in they absorb that energy, and there is basically this water in here raised up above the panel. So via gravity, the water is fed into the panel, and it starts filling up the panel. And as the sun strikes this panel, the energy from that milk carton transfers to the water that's within this grid here. And because the water in here starts to heat up, it becomes less dense, and the water in there is cold and more dense. So it automatically sets up the cycle. The warm light water rises up this pipe here, and the heavier cold water sinks down this pipe here, and it sets up this automatic cycle called the thermosiphon effect. And you will see that the water here is actually being pushed up. You could say, in a sense, against gravity. It's being pumped by this difference in temperature and pressure. But there's no pumps and there's no elements. There's nothing involved. It's just a natural, just using the power of science to set up the cycle here. And if you open up this lid, you can actually see the water being pumped in, even though there's no pumps. And you can see it's warm water, even though there's no elements. So this thing you basically just put in the sun, and the water in here heats up and heats up and heats up until the entire can is basically heated up. And as you can see here in this example, we raised up and we had multiple interlinked containers, and that is raised above the structure here. It's basically like an outdoor shower. So now this cycle, just put it in the sun and it starts cycling, and eventually it takes about 2 hours to reach about 40 to 50 degrees of warm water, which is very comfortable to shower. And so basically now you open the door, you go inside, and you open tap basically in warm water, because it's fed by, as above you, so it's fed via gravity into the tap, and you basically showering in warm water. There's an example of the temperature we're taking here, 48.8 degrees, close to 50 degrees. You can put it in your pool, you can put it in the bath, you can use it basically to anywhere where you need warm water. And then this was just to show you how simple the process is and how sort of the classes will entail. And so we take plastic piping, we cut it into different sizes, and we form that grid I spoke about. And then we paint it black so they can absorb the energy of the sun better. And then we take the milk cartons, dry it out, paint it black as well, again to absorb more energy of the sun. We cut the bottles to allow it to be interlinked in this panel, and then we just assemble all of it into. So we have the grid, we have the bottles going over there, the milk cartons in there to get this panel, and then we run some tests, and then we connect it up to the shower, and we have a solar shower. So obviously for me, the process involved understanding how a solar geyser works, understanding the physics principles, studying the textbooks, and then building, troubleshooting until eventually I got it right. And now it's basically been mastered. If you want to check out some videos, you can check out the Green New World, TikTok, Instagram, and LinkedIn pages. And then this is like a solar geyser, like I said, more high tech. So this uses, as I said again, energy, like a solar geyser. This is a structure made of wood, and behind this we have an aluminium sheet which is painted black. Again, we use a material that absorbs the energy of the sun, and then behind it's like a styrofoam, thick piece of styrofoam which prevents the heat that we're trapping from escaping. Over this whole thing is glass. Glass acts as the plastic bottles which traps the energy of the sun. The aluminium sheet at the back here acts as the milk cartons which absorbs the energy of the sun. That energy is then transferred to the piping, the grid here. And again, we use the same thermosiphon effect to heat up the water. No pumps, no elements involved. We just put it in the sun and it heats up. And this system actually became so hot that these pipes actually melted. And the water didn't leak down here, it was steaming up, which means that it's most likely we could have possibly hit 100 degrees with a system. I mean, a homemade system we built and we achieved such high temperatures, shows the efficiency of the system. And I mean, that is the first prototype. So it just really shows the possibilities. And so this system can basically be set up in a yard and then fed to your bathroom. You can pipe it out. If you raise obviously this above your bathroom, above your kitchen, and above the front, then you can basically open the window and you have like off-grid supply of warm water. Whenever you want to wash dishes, you open the window, just as an example. And this is just like a shower, also built outdoor, which is fed from the warm water. So as you can, you just use gravity to feed it into the shower, and then you have free warm water. That's just literally just standing there, and in 2 hours you just get in and you shower, and you pay R0 basically for the energy that you use to shower. Then just to touch on this, 3 minutes left. So this is a green hydrogen, basically educational kit, a model that I built, and I think I was the first to actually build this kit in Africa to show the people of Africa that it is possible to use their own resources, to build their own technologies, to solve their own problems. And it's basically a water to fuel and electricity kit. And the way this works is that you have water, and that's just a model to show how we can implement this on a much larger scale. The water is fed into what is called an electrolyzer, and we apply a current to the water, and that electricity is supplied by solar energy. So this is like a light, but it mimics the sun. So if you put the system in the sun, it will work even better, obviously, but equally as good. So the solar panels convert the energy of the sun into electricity. Electricity goes into the water. It splits the water into hydrogen and into oxygen, and the hydrogen is fed in here and it builds up at this point. And that production of hydrogen is basically called green hydrogen, and that is definitely the future for South Africa. As I showed you, the resources where we are the number one supply of platinum in the world, which is used as a catalyst in these technologies basically. And this hydrogen we can use in either to convert either as fuel or as we can convert it to electricity. For example, a hydrogen fuel cell car. If we have this in a car and we have this as a fuel tank, so we basically pump hydrogen into the fuel tank instead of fuel. That hydrogen is fed into this fuel cell. What the fuel cell does is it splits it into protons and into electrons, and that protons go through the membrane, and the electron can't pass through the membrane, so it's forced through the wire. When an electron passes through a wire, we have electricity. That electron goes to the fan and gives of its power over to the fan, and the fan spins. And the electron goes back and meets again with the proton, forming the hydrogen gas again, and combines again with the oxygen, forming water. So basically, water is the only byproduct. So in essence, we split water apart and we put the water back together and we get electricity out. So obviously, this we can implement on a much larger scale. We can have solar panels next to the ocean, converting the ocean into a green hydrogen, shipping that to the rest of the world, using it to power the land. So we want to get this into schools and possibly universities to teach and inspire the youth about green hydrogen, about renewable energy, about what is possible, about how we as Africans can build our own technologies using our own resources. So again, this example of converting complex knowledge, like I had to do lots of research to actually build this, but now we have the knowledge, we have the technology. Now we can speak to the people in a simple language, in some simple English, not complex, and explain to them how these things work, and give these technologies to them. And this can become projects in schools, and they can build these technologies and also inspire them to follow career paths that will allow them to eventually build these technologies that can solve the problems that exist in South Africa and in Africa. And this is the last one. So at UWC, we're currently building this mobile UPS system. So it's a battery pack with an inverter and everything else on one sort of mobile trolley. And we want to use obviously this to then solve the load shedding issue. So the students is actually building this. I'm assisting the students currently. And this is a student who designed this on SolidWorks. And the students is cutting, grinding, they're doing the welding, they're bolting it up, they're painting the thing. And so they're basically getting trained up from the beginning, from design to procurement to building this entire thing. And by the end of this training program, they'll be able to build these systems easily. And what we want to do is, these engineers, electrical and mechanical engineers, who now has this knowledge, then go to TVET colleges. They can then teach the technicians and the artisans to manufacture these things. And so we transfer it from us as from the engineers, and then we can move on to another technology, then transfer that to the technicians, the artisans who can then build it, who can start their own businesses. And so we're teaching, we're empowering them to in entrepreneurship, in building prototypes, in testing prototypes. So, and I just was 1 minute on this quickly. This was just a case study of what is called, you can go do your own research on this. It's called the Barefoot College, and it was founded by Banker Roy. He did this exact same thing where he went into India and took the poorest of the poor and trained them up into becoming solar engineers. Those women, mostly women, builds their own solar panels, builds their own solar cookers, and they are busy training others to build it, and they are busy electrifying their villages, spreading energy. And this is sort of why I put this here, was the exact same vision as Renewable. And obviously, so if South Africa and the government and companies buy into this idea, we can also achieve this exact same thing. We showed you why we need to shift. We showed you how we can make the shift, that it's all possible, that it's already happening. We just need more funds. We just need more resources, and we can really make some big changes in South Africa and in Africa, and we can achieve this this dream of the community coming together and building these sustainable energy systems. Thank you so much.
Okay, so I'd like to say thank you very much, Ridaa. I hope you all enjoyed this amazing presentation. Let me just introduce myself. My name is Imra. I'm from the Cape Town Science Centre, and I will be responsible for hosting the Q&A segment of the webinar. So we have a few questions in the chat, so I'm just going to head over to that and read out the questions. If any of the people present have any questions, you can just post it in the chat and we'll read it for you guys. So we have one question from Jane Clay Bester. She says, or asks, which areas in Cape Town are you and your team working in to introduce these sustainable energy systems?
Okay, so when we started off, many people was interested in the knowledge, and we were having a lot of classes from this house in Grassy Park in the southern suburbs. We were mostly there, and then the system is currently standing on a farm in Philippines, and so the classes moved to so again southern suburbs. At that point, lots of people were coming there. Then a lot of people asked me to come to the schools. But unfortunately, that wasn't economically sustainable to sustain myself. And so I had to sort of, in a sense, partner with UWC to build, to sort of, so in a sense, Green World is sort of housed at UWC now at the moment, whereas the director there, my director, his vision is aligned with my vision in building the systems. And so I'm currently working there now as a sort of training graduates. So UWC obviously available, but we want to obviously whatever funding allows us to do that is the issue. So if funding allows us to actually go into like the more poor areas and have these training courses and set up training facilities there, we would like to get into the more poor areas. So that's a big factor that steers it, is the funding, whatever funding is available.
Okay, thank you so much for that response. I hope that answers your question, Jane Claire. If there are any other questions, you can post it in the chat. We'll leave it open for the next few minutes. Okay, so from the Cape Town Science Centre, we have a question. We would like to know, for an average household, how much would it cost for us to install solar panels?
Okay, so a good system would probably need 100,000. So that is the big issue right now about the price of. So you need basically, so that you don't only, if you want to have a completely off-grid system, you must have the solar panels with the inverter, with batteries. Because if you only have the solar panels, you can only use the energy of the sun when the sun is out. But when you have batteries, you can basically use the energy of the sun when the sun is down as well. And so that's why the cost of the system becomes so expensive. I'm not an expert at the prices of things, but that is how much I was told to have. I wanted to install a system at this house. That's the amount that I was told to get if I wanted to install the systems. But you can gradually bring the price down by, for example, just having solar panels. But that will obviously limit you to just using the electricity, the energy of the sun when the sun is out. And then you can remove the inverter as well, which is also quite expensive. But that you can only then use DC. Most of the appliances in your house uses AC. That's why you need an inverter to convert it basically from DC to AC. So those are always you can cut down the price of the full system. For example, that system I showed you now, we're going to be selling that system for 65,000 rand. That is basically a 5 kilowatt hour system with battery, on the battery pack and an inverter. So you can get the more or less understanding of the prices of the inverter and the battery together. So obviously we start adding solar panels that you start to get the amount starts to increase. So and the reason why prices are so expensive is because, like I said, we're importing basically all the solar panels is basically being imported from China mostly. And so once we make the shift from producing the solar panels ourselves, and once we mass produce those solar panels, the price will basically start coming down, and that's when people will start having access to those. But our idea is to build those solar panels ourselves to completely bring down the price.
Okay, so thank you so much for answering those questions. I would like to thank you again for the great presentation. It was a pleasure to have you with us this evening. Before we conclude this webinar, I would like to say that the National Science Week is an initiative of the Department of Science and Innovation that is implemented by the South African Agency for Science and Technology Advancement, also known as SASTA, which is a business unit of the National Research Foundation. So this concludes the webinar. Thank you all for attending. We hope you have learned and enjoyed this presentation, and we hope to see you again in our next set of presentations. Thank you so much for joining us, and thank you again to Ridaa Manuel.
Pleasure.